Okay, let's see another scenario where we have to verify what will happen if we'll send duplicate Kafka message. So our expectation is there should not be any duplicate order in the database as part of that particular Kafka message. So uh, what we will do, we will send an order request to producer. It will process that particular request. It will send that event to the Kafka, and Kafka will save that particular order in the MongoDB by using the consumer. Okay. So in this flow, we will get the order ID. Maybe we can get from the producer response or we can get from the consumer also. Okay. By using this order ID, we will fetch the Kafka message from the Kafka order topics. Okay. So we will get the Kafka message. What we will do, we will use the same Kafka message to publish the event to the Kafka again. Basically, we are going to publish the same Kafka message as part of same order ID to the Kafka. Then we will go to the MongoDB and we'll see there should not be any duplicate order. This is what we have to verify. So this is the test method, and we have before should where we are creating all the containers before method to set up the reports. Okay, so we will create some properties of the order like product ID, initial stock should be 100, order quantity 2. Then we're going to set up a collection in MongoDB. Basically, it's a test data where we are going to create a product collection. Product ID will be the same. We are giving the product name, then initial stock should be 100 and the price. After that, we are going to save that collection to the MongoDB by taking help of MongoDB client. Now we'll create a order request object. This will be the payload. Then we will send a post request to create the order using this payload. We'll get the response and we'll verify if the order creation is successful or not. Then we'll get the order ID from the response. We will use the same order ID to fetch the original Kafka message from the Kafka. Okay. Now what we'll do, we'll publish same Kafka message to Kafka again. You can see we are publishing the same original Kafka message. Okay. We'll wait for 3 seconds. Then we have to verify MongoDB have only one record for that particular order ID. This is what we need to verify. Then we are fetching the order collection, then finding the documents which have the order ID this. Then we are verifying if the order count is one or not. This is what we need to verify, right? There should not be any duplicate order. Then after that, we have to verify the stock. Like we have order how many products? We have ordered two quantity. So there should be 98, right? So in products collection, we are verifying the stock should be initial stock minus order quantity, still the 98. This is what we are doing. So let's execute this scenario. So you can see it started the containers. Still consumer and producer didn't create it yet. Okay, now it's created the consumer, now it's the producer. Containers, all containers are up and running. So we are sending the order creation with this payload. Okay, so we got the order ID. Then in MongoDB, we fetch the collection order, right? Where quantity is 2, is telling processed, and products collection you are validating, it should be 98. 100 minus 2, 98. Okay, so this test got passed now. Okay, so let's see another scenario where we'll be going to validate what if we are sending a malformed Kafka message to the Kafka. Okay, so to do that, what I have did is I have created a payload where the price value is not present. So that means this payload is not valid, and we are going to push this payload to the Kafka. Okay, so what you are expecting is that particular malformed payload will be not going to be processed by the consumer because here the price value is not present. Then it will going to return to the Kafka, and Kafka will place that event in the dead letter queue, orders dash topic dot dead letter queue. Then after that we'll verify one happy path where we'll send the request, we'll create a order, and it will send the event to the Kafka, and Kafka will send that order to the consumer, and consumer will store that event in process and store that information in MongoDB. Also, that particular event will be present in order topics. So this two flow we need to validate. So here is our malformed message where the price is not present. Then we have two topics. One is order topics and another is order dash topics dot dead letter queue. So we'll be going to push the malformed data to the Kafka. Then we are going to monitor the dead letter queue. So here we are just verifying if this particular message, this one, present in dead letter queue or not. Then in step 3, we are verifying still our system should be healthy, right? After sending a invalid message to the Kafka, we need to validate still our system is working fine. So to do that, we have a product, then we are sending an order request, then we are verifying that order request message event should be present in Kafka. Then we are verifying in MongoDB database that particular order should be there. That's it. So let's execute it. We'll see. Yeah. So it's created some of the containers, MongoDB, Kafka. Then we'll see consumer and producer container also here shortly. Here it is. Then okay, we can see we found that particular malform message in deleter queue. Okay, this is it. Let's see the report. Malform message checking in order topics or dead letter queue. We found the event in dead letter queue, and see what's the error here, like why this message is not able to process by the consumer. Here it is, validation error for order event, price field required. So we didn't provided the price field, that's why consumer not able to process this event. So it sent back this message to the Kafka, and Kafka put this message in dead letter queue. Okay. Okay. Uh, let's see another scenario. Okay, where our database service will go down. Okay, so the basic happy path is we are sending the order request, is reaching to the producer, and producer will process the order payload and publish an event which will reach to the Kafka. Kafka will receive the event and it will place that event in order topics. Then from that order topics, consumer will pull that event, process it and save to the database. This is how it was happening. Okay, when server is up and running, everything is fine. But what if this MongoDB service went down, right? So in that situation, consumer will be able to process the data, but it can't save the data to the MongoDB, right? Because service is now down. So what it will do, it will going to check the connectivity continuously in some time interval. Okay. Until that moment, it will not going to increase the offset in the Kafka order topics. Okay. So once the server is up and running, once consumer will feel like okay the server is working fine now, it will going to pull that message from order topics again and it will process it and it will save it to the database. After that, it will increase the one offset of this order topic. Okay, so this is how the consumer will behave that time when the server is down. So let's see it lively. This is the test scenario. We have test database connectivity interruption. I'll be going to give some debug points so that we'll see in Docker what is happening. Okay, document pause on pause. Okay, pause. Okay. Okay. So how will we going to validate this scenario? We have created a payload, or you can see this is a MongoDB collection because we have to set up our database first. So using MongoDB client, we have created a product there. QA resilience, order quantity 3 we have to use, and we have told 50 stocks needed and price is 150. So by using this information, we have created a product, okay, inside the product collection. After that, we are bypassing this flow where we are sending request, it will go to producer and producer will publish event to Kafka. During test execution, instead of sending the payload or invoking the create order method in producer using post request, we will be going to directly publish a valid message to the Kafka. So to do that, we have created a order ID, then event ID, then timestamp, and the order message. In that order message, we have event ID, order ID, product ID, order quantity, price, and timestamp. Okay. Now we'll use the Kafka producer client class to send this order message. And which topic you are targeting? Orders topic you are targeting. So this message will be going to save in the order topic. Okay. So what's next? So next flow will be consumer going to pull that event from the order topic and it should process and save it to the database. This is how it, it should be, right? But what we are going to do is we are going to uh, somewhere we are going to pause that one. Okay. Okay. So here in this step, what we have did, we have paused the container, the MongoDB container. Okay. Before sending the message event to the Kafka. Okay. So what will happen? The container will be paused and the connectivity will be lost. Then we are sending the message to the Kafka. Then after some time, we are again starting the container, MongoDB container. So this can be called as connectivity back. So we got our connection, right? Then what you are expecting is even though the database server came online after some time, it should be able to save the data Okay, the consumer should be able to save the data in this database. So we are validating these things here. Okay, so let's execute this test, and I will be going to show you guys in this Docker how things are happening. Let let it start all those containers here. Mostly we'll be need this consumer container. We'll go inside this consumer and we'll see what's happening. So now where it stopped now? Okay. So we are going to stop the MongoDB container, right? We can see this is running now. Let's go to the next step. So it will be going to stop that container. We can see that MongoDB container now gone from here. Okay. That means MongoDB server is offline. Let's go to the consumer now, inside consumer container, and we'll see the logs here, what is happening. Okay. Then, okay, we are about to send message to the Kafka. Okay, let's send the message. Okay, and we'll wait before bringing the MongoDB server online. Okay, let's, okay, now we successfully send that event to the Kafka, and now we are waiting here to bring the MongoDB server back. But before doing that, okay, let's see the log. Okay, okay, our consumer now received the event from where? From Kafka, but database insertion got failed, which is expected. Why? The timeout, because the database server is offline. Correct? Now let's go. Now let's go back here and let's bring the MongoDB server back online. Okay. As you can see, it will keep trying. The consumer will keep trying to look for if there is any connectivity with the MongoDB database. It okay. It will continue like this. Once it will come back online, so let's do that. Let's bring back the container. Okay, you can see once the container came back, suddenly it's updated the stock, okay, quickly, and it successfully processed and commit this order. This is the order ID, okay. And if we'll go back, we can see the MongoDB is up and running. This is the proof. Once that came back online, consumer processed that one and updated in the database. Okay. Then now let's continue and see the report. Yeah, producing message. Then we just wait for the database to go offline. Then again we are starting the MongoDB container, and inside database we can see the order got updated. Processed quantity 3, and this is the product ID. QA resilience. If I'll go to here, okay, it's got stopped now everything. Okay. So this is the product ID. We saw the QA resilience.